Find a polynomial of degree 3 with rational coefficients that has zeros x equals 2 and x equals negative 3 halves plus 3i root 3 over 2. Since x equals negative 3 halves plus 3i root 3 over 2 is a 0, then x equals negative 3 halves minus 3i root 3 over 2 is also a 0. We will find the polynomial by multiplying the factors x minus 2, x minus negative 3 halves minus 3i root 3 over 2 by x minus negative 3 halves plus 3i root 3 over 2. In other words, we will subtract each of the zeros from x inside the parentheses in these factors. We can simplify this multiplication process by distributing the negatives through the inner parentheses in the last two factors. So we'll wind up with x minus 2 times x plus 3 halves plus 3i root 3 over 2 times x plus 3 halves minus 3i root 3 over 2. We will begin multiplying these factors by multiplying each of the terms in the factor x plus 3 halves plus 3i root 3 over 2 by each of the terms in the factor x plus 3 halves minus 3i root 3 over 2. When we do this, we'll wind up with x squared plus 3 halves x minus 3i root 3 over 2x plus 3 halves x plus 9/4 minus 9i root 3 over 4 plus 3i root 3 over 2x plus 9i root 3 over 4 minus 9i squared times 3, which we get from multiplying the square root of 3 by the square root of 3, over 4. We notice that in each of the terms that contain I to the first power, there is a like term with an opposite sign. So all of these terms will cancel. And the result will be x minus 2 times x squared plus 3 halves x plus 3 halves x plus 9/4 minus, and then we will note that I squared is negative 1. So we will have 9 times negative 1 times 3 over 4 in the last term. So now we will simplify this second factor. So we have x minus 2 times x squared plus 3x, which we get when we add 3 halves x plus 3 halves x, plus 9/4, and then when we cancel the two negatives in the last term and multiply the 9 and the 3 in the numerator, we wind up with 27/4. Now combining 9/4 and 27/4, we wind up with x minus 2 times x squared plus 3x plus 9. So now we will multiply these two factors by multiplying each term in the first factor by each term in the second factor. So we will have x cubed plus 3x squared plus 9x minus 2x squared minus 6x minus 18. Then when we combine like terms, we wind up with x cubed plus x squared plus 3x minus 18. So now we have found a polynomial of degree 3 with rational coefficients that has the zeros x equals 2, x equals negative 3 halves plus 3i root 3 over 2, and then we infer from this 0 that we also have the 0 x equals minus 3 halves minus 3i root 3 over 2.